Welcome to our deep dive into the controversial world of electric vehicles. In this video, electric cars are not the future. The shocking truth about EV batteries. We'll explore the hidden truths behind EV battery production and usage that many proponents often overlook. From the resource-intensive processes involved in making these batteries to the environmental concerns surrounding their disposal, we'll unravel the complexities of this emerging technology. Join us as we discuss alternatives to electric vehicles and shed light on the challenges that could redefine our understanding of sustainable transportation. 1. Resource-intensive battery production. Producing electric vehicle batteries is not as green as it seems. The process requires significant amounts of lithium, cobalt, and nickel. These minerals are not only scarce but also come with a hefty environmental cost. Mining for these materials often leads to deforestation, soil erosion, and pollution. For instance, lithium extraction has been known to drain water resources in arid regions, affecting local communities and ecosystems. The demand for these minerals is skyrocketing, raising concerns about their long-term availability and the environmental impact of their extraction. This resource-intensive process casts a shadow over the perceived environmental benefits of electric vehicles. 2. Environmental footprint of battery disposal. Once an electric vehicle battery reaches the end of its life, the disposal process poses significant environmental challenges. Improper disposal can lead to soil and water contamination, as harmful chemicals seep into the ground. This contamination can disrupt ecosystems and pose serious health risks to humans and wildlife. The lack of proper disposal infrastructure exacerbates the problem, leading to an accumulation of hazardous waste. As the number of electric vehicles on the road increases, so does the potential for environmental harm from battery disposal. This issue underscores the need for sustainable solutions in the life cycle of EV batteries. 3. Limited battery lifespan. Electric vehicle batteries are not designed to last forever. Most have a lifespan of 8 to 15 years, after which their efficiency diminishes significantly. This limited lifespan raises questions about the sustainability of electric vehicles. Replacing a battery is not only costly but also adds to the environmental burden of producing new batteries. Additionally, the performance of an electric vehicle declines as the battery ages, potentially reducing its appeal to consumers. This lifespan limitation highlights the need for advancements in battery technology to ensure the long-term viability of electric vehicles. 4. Energy source for battery production. The energy used to produce electric vehicle batteries often comes from fossil fuels, which negates some of the environmental benefits of electric cars. Manufacturing these batteries requires a substantial amount of electricity, and in many cases, this energy is generated from coal or natural gas. This reliance on fossil fuels increases the carbon footprint of battery production, undermining the green credentials of electric vehicles. The irony is striking. A technology touted for its environmental benefits is, in part, reliant on the very energy sources it seeks to replace. This paradox calls into question the true sustainability of electric cars. 5. Recycling challenges. Recycling electric vehicle batteries is possible, but the process is complex and not widely implemented. This complexity arises from the diverse materials used in battery construction, which require specialized techniques for separation and recovery. Currently, only a small percentage of EV batteries are recycled, leading to increased waste. The lack of widespread recycling infrastructure exacerbates this issue, resulting in valuable materials being lost to landfills. The challenge of recycling highlights a significant gap in the lifecycle management of electric vehicle batteries, necessitating urgent attention and innovation. 6. Supply chain vulnerabilities. The production of electric vehicle batteries is heavily dependent on a few key countries for raw materials, creating supply chain vulnerabilities. For example, a significant portion of the world's cobalt comes from the Democratic Republic of the Congo, a region plagued by political instability and ethical concerns. This reliance on specific countries makes the supply chain susceptible to disruptions, which can impact the availability and cost of batteries. These vulnerabilities pose a risk to the scalability and sustainability of electric vehicle adoption. Diversifying supply sources and developing alternative materials are crucial steps in addressing these challenges. 7. Alternatives to EVs. While electric vehicles are a popular choice for reducing emissions, other technologies may offer more sustainable alternatives. Hydrogen fuel cells and biofuels are gaining attention as viable options. Hydrogen fuel cells produce only water as a byproduct, making them an environmentally friendly choice. Biofuels, derived from organic materials, can be a renewable source of energy. These technologies present opportunities to diversify our transportation energy mix and reduce reliance on electric vehicles. Exploring these alternatives can lead to a more balanced and sustainable approach to reducing transportation emissions. In conclusion, while electric vehicles offer a promising path towards reducing carbon emissions, the complexities surrounding EV batteries cannot be ignored. Understanding these issues is crucial for making informed decisions about the future of transportation and our planet's well-being.